All right, and now we come to the last phase in the software development lifecycle. So I'll remind you that we basically had the planning, which led to the analysis. And out of the planning, by the way, came a deliverable. That deliverable was fed into the analysis. The analysis basically spits out the analysis requirements. For example, the functional decomposition diagrams, the data flow diagrams, those fishbone diagrams, whatever, all the input outputs, processes, controls, and performance requirements. All that stuff was in here, and then it got fed into the design, and then the design spits out things like the ERDs. Oh, I forgot to mention, by the way, after the requirements, of course, you'd also have the use cases as well, and the activity diagrams, the class diagrams, things like that. So when we get into the design, we're getting now the ERDs, the user interfaces, the reports that we're expecting, that kind of thing pops out of those, until finally all that gets fed in to one glorious moment of implementation. Now, typically, this is it's a tiny wedge of the amount of time and effort that would go into the entirety, the total cost of ownership of a system, right, is basically building the system itself. And then out of that comes the system. And not just the system, by the way, but the documentation for the system, training plans for the system, that kind of stuff would come out of the system implementation. But this is a tiny sliver, and I wish I could remember the stat, but it's definitely less than 10%. Okay, so there is a sizable chunk here. We'll say, just for completion, we'll say 20% maybe, 10%, and 60%. And all that, go ahead and look that up, because I don't know. Certainly when I was giving my master's, the conversation was that this was easily 2/3. 2/3 goes into maintenance, all right? And so this chapter that we're about to talk about is all about maintenance. It's managing the system support and security. And so the topics here are what you're likely going to end up doing a lot of when you leave and get an actual IT job. Now, some of you already have IT jobs, and you can attest the fact that you're not necessarily building a lot of stuff. You're usually trying to fix a lot of stuff. When I say fix, we're going to talk more about that too, as to what maintenance actually is, because fixing is a bit of a loaded word sometimes in some companies. So I'm going to give you some verbiage for that. That'll make you stand out. So anyway, we're going to explain what system support, explain a little bit about this phase. We're going to talk about what user support activities, like how do we support users moving forward, because the same users that you had when the system was created might not be the same users you have a year or two later. So you do have to keep in mind that there's not just turnover in the IT staff, but there's going to be turnover in the people using your product. And even, by the way, for your IT staff, although this is talking about user support activities and user training and so on, you should basically have a way to keep your IT staff, which could be churning quite a bit, keep them being trained on how to support the system as well. As an example, by the way, if your shop basically does outsource a lot of stuff to India, and so you find that you're working in North America globally with Indians in India, the churn over there is about 2 years. It's about 2 years, at least in the company that I was at. You could expect an Indian to work there in that company for 2 years, and then they jump into another company. And no fault or fair, no problem to them. That was part of the business model. But I'm saying though that you did, as a manager, I had to prepare for that. I never ever let one person ever become siloed so they became the expert in that system and no one else knew anything about it, because that's not good for anybody, by the way. If you are that expert, then you will never get a vacation, right? Because your system will not likely ever work long enough that you can ever get a vacation. So you don't want to be the expert. And I'll also tell you, in all honesty, corporate doesn't care that you're the expert. If they're looking for someone to lay off, they'll lay you off anyway, right? So the whole idea of, I want to get the job security, be the expert, that's not a very good reasoning. You won't get any vacations, and you'll still get laid off. So in my mind, the best strategy is to spread the knowledge of the system around the team. and have maybe pockets of expertise where perhaps this pocket of group, this group of people will be an expert in one particular system, and this other group of people will be an expert in the other system. And you do want diversity in that as well. So anyway, I could talk forever on that, but I'm just letting you know, it's not just user training and user support. You got to make sure that during the maintenance phase that everybody on the team, well, not everybody, that's impractical, but there's a pocket of people on the team that are familiar with the system. All right, I said earlier that fixing systems is a little political. There's actually 4 types of maintenance. So when I'm saying fixing, typically that comes up as maintenance, and we're going to talk that there's actually, and this will make you sound a lot better in the IT world. There's actually 4 types of maintenance, and it helps, I think, upper management understand a little bit more about what's going on. Remember, you could easily be managed by someone that doesn't understand the technology or doesn't even understand even the processes, and it's up to you as a systems analyst and up to you as a programmer talking to a systems analyst to be able to communicate these maintenance ideas. So this is, I think, one of the most important things out of this chapter. Okay, risk is the other one that I think is also important too. So let's just go through. I never like doing the intros. Anyway, so here you go. Here's, speaking of intros. So the system support and security phase begins when you turn the thing on, and it actually, in all honesty, it starts being used, right? Until it reaches its end. The final phase, which isn't really talked about on this fabulous little waterfall model, the final phase really is retirement. There is a phase at the end, and retirement, which I'm thankfully dedicated a few slides to at the end of here, but retirement is definitely a phase. That's when you basically turn off the system. So this support starts when you turn it on, retirement starts when you turn it off. So after the system's delivered, the IT team might not even be the same team, has got to focus on support and maintenance tasks based on the expectations of the users, the performance of the system, and security requirements. So when it comes to user support, a lot of that is going to be in training. You got to have some training packets, and of course, there's just like in the previous chapter, there's a wide variety of ways to train users besides just simply face-to-face classes. Although that is certainly a good too. But you want your users to know how to use your product, or they simply will not use it, or they'll use it grudgingly, and those are both bad scenarios. You want your users to be able to use your product, because remember, they don't really want to use your product. They want to get their job done, and they're using your product to get the job done. I'm not sure how many people like hammers, as in tools. It's not the hammer that's important. It's the job that the person is using the hammer for that's important. So thankfully, a hammer is very simple to use, and I never have to think about using a hammer. If a hammer was really complicated to use, I'd probably just go out and use a rock. And that's what I want you to imagine with the tool, right? The tool is, your product is a tool. No matter how much in love with it you are, it is basically a tool that's meant to enable a particular process. And so you want your users to be able to use it. Now, hopefully, if you did your work properly with the user interface, and if you were listening to them in the first place when you were designing it, it will be relatively easy to train on, right? Hopefully that will be the case. A hammer is a pretty intuitive thing, right, to use. At no point am I ever tempted to take the handle of it and try and drive a nail in that way. But I'm just saying that, basically, video games are a really good example, to be honest, because the easier it is to play and the more enjoyable it is to play, people will go to play it, right? And that's what I want to get to there. All right. So help and service desk. So, okay, many of you actually end up on a help or service desk. So this is kind of an important thing for you guys. You're trying to provide support and guidance. Understand that whenever anyone calls you, they're probably under distress. So in my mind, if I can just borrow from a ministry background for a minute, one of the sole purposes of a minister in many cases is to be a calm presence in faces of sometimes incredible stress. And so I would say to you, regardless of whether you're religious or not, to try and be the calm presence on the call, because whoever's calling you isn't calling you because they want to call you. And also, by the way, they probably have called you after trying several things, and they're probably already frustrated. So, so please be aware of that. See this happy guy? You want to be as much as possible a happy guy, and then use your breaks to go and detox on somebody else. All right. So that's the deal there. So the objectives of support, right? Show people how to use the system. Make them more productive by teaching them maybe how they can meet their own needs. One thing I'll say too about this role that you'd have, it's, you know, that whole deal about if you give a person a fish they can eat for a day, show them how to fish they can eat for a lifetime, that kind of thing. Well, that's very true here with this. You can help fix the problem that they've got, but the other thing to do, which I've been so appreciative of on some of my calls, is when they will then say, hey, just so you know, next time you can do it like this, and it's like, oh, good, and I'm enabled, right? And that way I don't have to call them back. Also, by the way, a lot of this stuff is tracked as well. Not a lot, all of it's tracked, right? Certainly at Oracle, they had tons of statistics about people, what product were they using, what was their basic problem with it, and all that. And that information then gets fed into the next iteration of the product. So you actually do have a very vital role. And I think in a well maintained or managed, I guess, call center, it's a pretty good deal for an introductory position for a college student in a well managed. Now, some of these things are not well managed, which is really unfortunate. But in the well managed one, it's actually a pretty good start in the industry. So so anyway, I'll just say that I personally, by the way, I've never had a chance to work in it because they didn't really have these as much when I was coming on board. I guess to some degree I kind of was tech support, but I was tech support in that people would come up to me, the users would physically come up to me and get me to try and fix their problems in the beginning. All right, you guys are all aware of this idea, I imagine, remote control. Basically, in the Windows world, it's RPD, RPD, remote. Well, that's gone. Anyway, whatever. The point is basically going in there and having them look at your PC the way that you're looking at the PC. Remote Desktop Protocol, RDP. Thank you. I don't have anyone here, by the way. It's just me. But anyway, I know I'm actually tech support for my mother, and it is remarkably frustrating. So a lot of times, what I'll do is I won't actually use RDP, but what I will use is Zoom or something like that, or WebEx before that, to go in there and look at their screen, maybe control their screen. Obviously, you're being incredibly careful when you're doing this. Make sure you're actually talking to the company and make sure the company's reputable, because of course there's a whole bunch of hackers out there that use this to take over your systems. So outsourcing, so offshore call centers. I am absolutely confident you're all familiar with this, right? There was a big push to basically push all the call centers off to cost-effective countries. And I think some places have now pulled that back and some have not, and that's just up to the individual company. I'm actually pretty happy, like my financial companies have tended to keep the call centers here in North America. I think even some of the IT companies are pulling them back now. And I think with this idea going on, and actually thanks to COVID, by the way, COVID-19, a lot of people now working from home, we're starting to see probably even more now, more of that technology kind of coming back into North America. But anyway, all politics aside, I suppose, it isn't that bad of an idea if the call center, again, is well managed, right? And your tech support does matter. Remember what I just said earlier. Nobody's using your product because they want to use your product. They want to get the job done. And if it turns out they can't get the job done with your product, they will move to another product. And if people are waiting on the phone for like hours, or if the support people aren't all that great, or if they have no other options to get what they need done, they're going to move into another product, and that's bad. So you've seen this chart before. I brought this up when I was talking more about the total cost of ownership and payback analysis. But this is sort of a good example here that the system itself, even if you get to turn it on and run it for like 3 blissful years without any maintenance done, well, not maintenance, but any work done on it, there's going to be some cost that's just straight operational, which is maybe the machine sitting in a closet, or you got to probably run patches on it. You've got to, power, there's cooling. There's going to be things, or even retail space retail space. That's not the word I was looking for. I don't know now what I'm talking about, but basically the space it takes inside of that room, you're being charged for that. So anyway, there's those kind of costs which remain pretty fixed. Obviously, there's the building of the system, but at no point really will this ever go down to nothing. And even if it does go down, there's going to be, peaks probably as the business shifts and changes. And at some point, there's going to be a great big peak. And if you're not paying attention, that peak is going to be, they're going to make the decision here. Nope, this is too much. We've got to come up with another solution. And then we retire it, right? Either with a straight cut over, or the phased cutovers and all the stuff that we learned in the other chapter. This is one of the most exciting slides on this particular adventure here of this chapter. So, maintenance. What in the world goes to maintenance? Well, I think most of the world thinks of maintenance as being corrective maintenance or adaptive maintenance. So corrective maintenance is basically fixing something that's wrong. So the system broke, and now we've got to fix something that's wrong. And I think upper management views maintenance a lot like corrective maintenance. So if a system's generating a lot of maintenance, they'll tend to get a little bit cheesed off at it, because it's like, well, obviously there's a lot of stuff wrong with it. The quality of the product is pretty bad. But that's not all that there is to maintenance. There's corrective maintenance. Adaptive is basically trying to get it to do something it wasn't initially designed to do. So I would say, and I don't know how many of you remember this, but Amazon originally really just sold books. I know it's hard to imagine, but it just sold books. Well, at one point they were trying to compete with eBay, and they came out with a whole auctioning system like eBay, and that was a new thing. So they would have to adapt, I imagine, Amazon systems to have a sort of a new auctioning thing. Or at one point they started selling CDs, right? And now you can imagine as we move forward, we've got Amazon Prime and all that stuff. But what I'm saying is that the system gets adapted to do something it wasn't initially designed to do. Now there can be minor adapting and major adapting, but I mean, this is what that's about. But there's another two worlds to maintenance. One is perfective and one is preventative. And I wish that upper management would understand this, because here's the deal. Perfective maintenance is getting it to run better. So maybe the thing actually did work, but now we can actually get it to run better. So a lot of this is sort of in the background, but I'd imagine that maybe you've discovered in your database there that that this query could be a lot more efficient than it is now. So you go in there and you change the query and reduce the runtime of the query. I was able to at one point take a query, or take actually a whole process that would take hours, and brought it down to 2 minutes, because I discovered a lot of unnecessary stuff happening in the query, and I was able to sort of trim it out, redesign it, and all of a sudden, boom, I perfected the query, made the thing run faster. Now, I didn't adapt it to something new. I didn't correct anything that was wrong with it. I just perfected it. I made it a little bit better. So that goes under maintenance, all right? Because I'm not really building anything new. I'm just making it run better. So there's an example, sort of a perfective maintenance, and it's a good thing. And when I was working on something, I'd always basically make it clear that this was perfective maintenance. And then preventative maintenance, a good example of that, for those of you who remember this, is the idea of Y2K, so year 2000. At one point, the digits were going to go from 2 digits to 4 digits. It was freaking everybody out. And in the late 80s, people who started to work on that problem, they were doing preventative maintenance because they knew that something coming was going to basically squash or destroy or destroy the program. So we would work to prevent that from happening. That's preventative maintenance. Now, in the late 80s and early 90s, preventative maintenance, that would have been what Y2K was. But once we started getting closer to the end of the century and things started to break, well, now that didn't become preventative, that became corrective, right? So preventative is basically people out there trying to, looking to see what are the potential problems and then fixing the system. So another example, which is fairly easy to understand, is maybe you're realizing that your database is about to run out of space. Now, there's nothing wrong with it. Your database is working just fine, but you are collecting information, and you realize that if you got DBAs that are on their job, they're noticing, hey, man, we are going to run out of physical space. It's one thing to run out of logical space, but actually realizing that your hard drives, that you're about to run out of space, and hopefully they give you a bit of notice for this. Then you start to come up with a plan. What are you going to do? Are you really going to keep all that data, or do you need to expand? Basically, grab some more space somewhere else. Those are the kind of conversations that happen. But all of that would be under preventative maintenance. All right, you're trying to prevent something from happening. Now, that's a discussion on the maintenance. Now, what's going on here? This is basically the life cycle of your system. So this is immediately after you turn it on. It's early life, middle life, and later life. So as you can see here, corrective maintenance, in the beginning, it starts high because, of course, the system, you probably haven't accounted for everything. So you got to go in there and constantly fix a bunch of stuff. But then you hope that it kind of goes down to almost nothing in the middle. I'll talk about later in a minute. Adaptive, you hope in the beginning when you turn on, you don't have to do any adapting, right? And then you might find it for minor enhancements, you might have to do some stuff right up through the end. For major enhancements, you hope again for the early part of the life that you don't have to do any major enhancements because you just designed it. If your requirement gathering and all that stuff that you did, if you did all that in earnest and you did a good job on it, this really should be pretty minimal in the beginning. And then, it starts to evolve as you get a bit later. Perfective. When you release it, it might not be totally perfect. And let's face it, we're all Windows users, so a lot of us can recognize that, yeah, when it gets released, it might not necessarily be perfect. But basically, perfective and preventative, they more or less follow the same flow all the way through. It's sort of as things come up, right? As things come up and you realize, hey, we could probably do this better. Certainly, by the way, up to this point, we can do things better, or we can maybe perhaps stop something bad from happening. They basically follow the same thing. In the beginning, not so much, and then somewhere, some reasonable activity around the middle of the life cycle. But what about at the end? At the end, well, the reason why corrective maintenance spikes at the end is because your system is starting to break. And if you've got a decent car, I'll tell you this: the Spencer family drives our cars into the ground. We really do. So we buy our car. We had a wonderful Ford Escape. It was a 2001, and it really did a great job until pretty well near the end. At the end, all of a sudden, it was spiking up in corrective maintenance, right? Things would be breaking all the time. As far as adaptive and stuff, this is probably happening because people are realizing they don't necessarily know we're near the end, right? The system isn't really designed to do what the business now requires it to do. So we keep doing a lot of adapting and stuff like that until eventually we're going to have to just start giving up, especially when we start to get some high costs there, right? It's like, is this still worth it to keep putting money into this system? I had to make a lot of those kind of decisions in my last job. We have this old system and the business has changed. I know we're going to retire it next year. Do we want to put all this money into that now, or just think about the new system? And it's, as I'm about to start the new job, I'm not going to look forward to those kind of conversations, but they're going to be out there because the business, I want you to understand, you could have the most perfect system ever, but after, I would say 5 years is like a lifetime. After 5 years, it probably isn't going to be able to keep up with whatever the business has evolved it to do, and you'll have to make those decisions. Do you want to keep putting money into that, or do you want to get a new system going? And as far as these guys go, perfective and preventative, well, you know you're more or less near the end, so you're not going to spend too much time on preventative, and you're not going to spend a lot of time on perfective because you're just about to retire the system. So this is a really good chart to have up on your wall or something like that to help sort of explain to upper management what kind of maintenance you're doing. It's not just correcting something that's wrong or adapting to new requirements. There are other things out there that actually also do require attention and cost money because somebody's doing these things, so it's going to cost money. Okay, so they kind of went through all that, and I'll let you look at that. All right, so the maintenance team. So who's on the maintenance team? Well, you might have a system administrator, maybe on your team, or at least you have access to this person part-time. There's the systems analyst. So here we are. We're investigating and locating the source of the problem and using our skills to try and sort of figure out how to fix it. Programmers will basically be in there to work with us. And by the way, systems analysts still program, by the way. So maybe all together we'll basically be, trying to sort of solve the problem. And understand too that when it comes to organizations, as I alluded to earlier, the team that builds the product might not be the team that maintains the product. There's actually a rule of thought out there that suggests that the team that builds it shouldn't be the one that maintains it. The argument is that the quality of the system will be better if the team that builds it has to then bring it over to another team to maintain it. And I see a little bit of wisdom to that. I can kind of see how if you're the one who built the system and then you're the one that maintains it, you're probably going to take a lot of shortcuts. You're not necessarily going to document things as much. You're just going to be in there tinkering around until the thing actually works. But if you actually have to build it and then hand your baby over to somebody else and then teach them how to do it, there's going to be a bit more of a stringent nature to that. So anyway, I kind of agree with that idea. I've sort of seen both, and obviously I'm waffling back and forth, but I do like the idea that someone else actually maintains the system. It also, by the way, spreads that knowledge, as I said earlier, it spreads that knowledge around. They've given some kind of beautiful code of ethics. Like anybody basically on a maintenance team, you're gonna have to figure out what is the actual code of ethics for your particular team. This is not a bad sort of example of it, so feel free to have a peek at that. Now, how do you actually get your requests? Well, sometimes you'll get a request, you got to figure out what it is, but there's going to be probably, just like the much earlier topic of projects, there will be more maintenance requests than you have resources to deal with, right? And so what has to happen, I think, is that it should be up to a committee to decide which tasks are important and need to get worked on first. As I've said, maybe you don't know, but anyways, I was laid off from one position, and now I've been hired into another position. And in the various interviewings that I did, this question came up quite a bit. How would you determine what the people should work on? And my common answer was that I don't want to be the person that determines what the team actually works on, because I, as the in this case the manager, but the manager in charge of the team, I don't necessarily know what's the most important part of the business. I don't. So what I want is to basically facilitate, get the stakeholders together, and have them look at all the requests and say, which ones do you think are important? And so in the world that I came from, we had the people, we had the finance people, we had the sales people, and we had the delivery or more operational people. And everyone thinks their own problems are more important. But when they get together in the same room, the finance people will say something like, well, if you don't get this done now, we're not going to be able to report our earnings to the shareholders. And all of a sudden everyone goes, you know what, that's important. You can work on that. Another person will say, and this is sadly a true story, if you don't get this done now, the president won't get their bonus. Well, I don't know how important that is to business continuity, but I know that the president wants their bonus. So that will take priority. Maybe the operational people might realize, oh, you know what? Okay, these are not as important. We can maybe do a workaround. Can you maybe get to this in a couple months? And those are the kind of conversations that happen in the committee. And so that's what I'm going to encourage you, is that if you're ever in a position where someone's asking you, well, which one do you think you should work on? You probably, as a systems analyst or a programmer, you probably won't know. So you need to basically bring the business in, or whoever it is that you're supporting, and get them to figure that out. And that's this whole deal with the priorities. Now, with all these requests buzzing around, there's going to be a lot of changes to the system. And the question is, how do you get those changes into production? How do you control the change that happens to the system? Because I'll tell you this, it is quite possible that your change, which you think is going to be good, could break something else, right? You fix this thing, you think it's beautiful, you throw it in there, and all of a sudden something else breaks. In my early career, I used to be in charge of this sort of stream of jobs, and the way this shop was set up, because they wanted things to be fast, is that the programmer would basically get the change request, make the change, and throw it into production, often with no documentation. And this was sort of pre-internet. So what would happen here is that I got a pager, if you remember what those are. I have a pager, and that pager would almost go off every night at 2 in the morning because something would break. And because this was pre-internet, I'd have to get myself up and go into the office and fix the thing. And most of the time, in my early part of that job, I was there, like my hours basically became 2 in the morning till 12. And it's interesting, upper management was mad when I went home at lunch, and I'm going, dudes, of course I didn't quite have the maturity or the spunk to say it to their face, but I was going, dudes, if you don't want me up here, if you want me to have an actual day, give me a normal day and not have this kind of change control. But I didn't even know what change control was then. So here's the deal with change control. What you want to basically do is, it's got to be some organizing and documenting of the changes. So a lot of times there's products out there that actually help with that. Now, a lot of the Git source version control, which somehow is called SVN. I can never remember why it's called N and not C, but anyway, these kind of products are out there where you can basically get your change, maybe combine it with some other changes and put it into a patch, document the change, maybe have a version number on it, and then release the change at once. And that's what we're talking about here by having release methodologies. Basically, grab all the changes and release them at once. The advantage is that you get a little bit more of that integration testing that we were talking about before, or even system changes. The disadvantage is that this isn't really continuous delivery, right? If you have this deal that you can only release your change, your patches once a month, then something that becomes an urgent, important thing has to wait a month. Also, in my world, where I was dealing with financial reporting, there were definitely blocks of time you couldn't put your change in, right? So there'd be this frantic push up to a certain point in time, and then we'd enter into something called a code freeze, where you couldn't change any code, because even if the reporting is wrong, it had to be available and consistent. So it could be wrong, but if it was consistently wrong, then the finance people were okay with that. They didn't want their numbers jumping all over the place while they were trying to report on the earnings. So so that was sort of a disadvantage. I basically have to make sure my code freezes lasted from about a week before the end of the quarter to 2 weeks after. So I had basically 3 weeks, and during that time, it's not like the developers didn't do anything. They just we were working basically on the next release. So that's the idea of a bit of discussion about releases, version controls. When you release everything, these version control systems, it's what you could do is, if it turned out that patch was wrong, well, first of all, you'd actually be able to blame what actually went wrong. So one of the first things I'd do whenever something blew up is I'd look at the module and say, who was the last person that changed it? And because of the way our systems were, I could actually tie that right back to the individual. I knew when that code went in. I knew who did that change. I could even track out what that change actually was, and we could sit there and discuss it. So you're going to want some kind of version control system. I think Git is pretty good actually. So definitely look that one up. It's GIP. Most of our time though, we actually spent using SVN because that's just what we had. All right. So there's Git right there. Little discussion there. All right. So now we're looking at this idea of fault management. So we're trying to monitor a system. Now at this point, we're looking more at, I'm imagining what we're looking at is stuff that just simply isn't working, right? Like not so much a coding level now. Maybe there's some kind of running out of memory or whatever. So this would be more of a not a systems analyst, but a network analyst's role, I would think. But it is important to understand, the workloads and the performance, because when the system's released, you don't necessarily have a lot of people on it. I know one of my systems went from having like 5 people to 100 people to like 10,000 people running on it, and we were constantly checking things like the response time. We were constantly checking how is the network doing, how is the database doing, how much data are we actually keeping? Are we going to run out of space, as I mentioned earlier? So basically, you want to be constantly during the maintenance, measuring the performance of the workload. Some shops I actually I got to see, they'd have their walls would have several TV screens up where there'd be tons of these kind of graphs out there, and they'd be actually watching them. So there you go. But honestly, you're not necessarily going to be watching them, right? Because these are systems. So as I mentioned in another context, if you find your system's getting ready to redline, we actually had it where emails would be shot out to us saying, "Hey, you're about to run out of space. Hey, you're about to run out of your processor is running at 99.8%." These kind of things, and then we would go out there and try and figure out what's actually going wrong with it. All right. So the capacity plan, and this is what I wish we'd done a little bit better. When I mentioned earlier the 5 to 100, we were never supposed to go beyond 150, but then to jump to 10,000, that would have been nice to know that was what was going to happen. So when we found that was going to be on the plate, we had to basically sit there and do a lot of what if analysis. What if we did go to 10,000? What would that actually look like? And basically start planning for the future activity. All right, and they got some stuff there to talk about there. All right, so maintenance tools. So remember CASE, computer assisted software engineering. So anyway, they're saying many CASE tools include system evaluation and maintenance features. Even some of the basic ones that I've used do actually have that. They have the ability for you to go look at that, what's going on in the mind, in my case of the database, what's going on in the mind of the middleware. And then, however, we still end up using a lot of spreadsheets and PowerPoint to basically sort of present stuff, especially to management when we're trying to beg for new machines and new resources. Now, full disclosure, security is one of my weakest areas personally, so I can't really talk too much about that. Very similar to chapter 10. I can't really talk too much about this other than saying what the slides say, but it is interesting, especially when I was dealing with data, that I did have to deal with this quite a bit. I had to basically, was the data any good? So so we got integrity. Was it any good? How secret do I have to keep it, and how available? And so, for example, when I was dealing with, let's just say, usage of our stuff. So if that person was accessing our stuff on their corporate account, it was available. If that person was accessing our stuff on a Gmail account, it all of a sudden became confidential because your email account is personally identifiable information, so PII. And there's a constant tug of war really between how secret is this information to how much can we use it. And if, like, let's say 30% of the people were accessing this thing off of my off of their personal emails, which shouldn't have happened, by the way, I'm losing. I got this big blank space there that I can't figure out, well, what's going on in that 30%. So this kind of stuff goes on all the time, at least in business intelligence, this sort of battle between these two. And so I'm not surprised it's sort of sitting here in the triangle. So when it comes to risks, now here they're going to be talking about risks, right? Yeah, they're talking about basically the risks. Oh, geez. security risks. Let me just blast through that because I ended up hitting the home button for the high quality videotaping I'm doing here. All right, anyway, so this risk is going to talk about all the various stuff for security risks. And actually, I don't know, I'm wincing because I think the chapter's changed a little bit from most of the time when I've talked about this. How about I'll put a pin in that thought and I'll just keep going. All right, so we got risks of security threats, right? And in a minute, we're going to get to go see a whole bunch of these kind of threats. And actually, I would like to talk at least about a few of them, but I'm not going to read all of them, all right? But what we got to try and do is figure out what are the threats, how likely are they actually going to happen, and what are we going to do if they actually do happen? So here, they're talking about these are all different kinds of threats, and these are all examples of those threats. And I don't even know how much I want to basically get into individual ones of these. I'm thinking it is interesting to me, by the way, I've had to deal with a lot of these. Like, for example, we had a lot of people, we had a data center in Chile, and Chile had an earthquake, and it took out the data center. And that was kind of a big deal, right? We had to deal, it's not so much a natural disaster, but we had to deal with riots erupting in a different country, and that shut down that particular country, which shut down our data. Obviously, you know, Oracle, like other companies, has a lot of older hardware and software running stuff, and that stuff is under constant attack. That's sort of basically like a threat. Plenty of this, I even did this. I actually deleted 3 years worth of data. And this, I'd like to say this is my early career, but this was only about 2 years ago. And so I became a threat. It was a great moment in my life. And thankfully we were able to get it back, but only after a bit there. And I did appreciate my boss's calm demeanor, because I think he was only calm because he liked me. But man, that was I did a dumbass thing. So just remember, if I, after like 30 years in this industry, can do a dumbass thing, you certainly can't do a dumbass thing. So don't do it. All right, so what other ones do we want to talk about here? So now we're just basically talking about different types of hackers, or at least attackers anyway. So again, look over that. Different kinds of attacks. Again, you can just look over those and read them. And some of these, by the way, are new to me too. I thought it was kind of interesting. And then when it comes to looking at security and being secure, you got to secure the physical stuff. And what I'm thinking about here, and the only bit I can maybe talk about, is the actual physical safety of the machine is important. Like in Oracle's case, these machines are always under locked doors in safe rooms. Interesting enough, another company out here, Thomson Reuters, they built their database in a bunker that could withstand an airplane crashing on it, because they had airplanes flying over top, and they knew, not over top, but, you know, they were on an air traffic lane, whatever that's called, and they their livelihood was their data. They could not withstand an outage of even an hour. So they basically had to make sure that this thing could withstand an actual hit from an airplane. So I thought that was kind of interesting. Network, many of you guys are more proficient in talking about how you secure that up. So I don't know, look that one up. Applications. I know when it comes to some database applications, there's something called a SQL injection, where there's a free text field and something like, you know, search by last name or something like that, and you put the last name of, let's say, Spencer, but then you type or 1 equals 1 or something like that. And then what happens is that all of a sudden you get to see all the names rather than just the last names of Spencers. I mean, SQL injections, we had to basically spend a lot of time coding our applications so they wouldn't basically be able to be subjected to goofy things like that. How safe are your files? Are they encrypted? How are the people ultimately using your stuff? How safe are they? And so they're going to talk individually here about the physical security. I know in Oracle's case, by the way, and I'm sure most other cases, whenever we're walking around laptops, they are actually encrypted. In theory, our phones are supposed to be encrypted. So I'm not even sure if mine is encrypted anymore, but it's supposed to be encrypted. And what else did I want to say about that? You walk around those little USB slots encrypted. Okay, so here's the security stuff. Oh, VPN, of course, yeah, virtual private networks. We definitely use those when we're especially working from home or out of the office. What is a VPN? So a VPN, what that basically does is I can be on my laptop, basically my Wi-Fi at home. I log in through this VPN, and now I am on the network at the office and not on my network at home. So it's so for an easy example, when I was just on my network, I could use my home printer. As soon as I go VPN, I'm now using the office printers. So it's basically like a virtual private network. It's like it sounds. All right, definitely I don't know enough to talk about firewalls, but many of you do, so feel free to look that up. And this is kind of a neat idea. When some of my initial coding, you'd actually see this. You'd see in the URL or some kind of thing, the actual password echoed back. That's obviously horrible. So, but I haven't seen this in quite a while now. Most of the time when you're seeing passwords, they're pretty well encrypted. Okay, and we'll just forget all this stuff and let you read all those on its own. And there we go. All right. One of the things I thought was in here, but isn't, is this idea of risk mitigation. And they were kind of giving a little bit of that. But what risk mitigation basically means is, do you have a plan for if something goes wrong? And so, for example, what's the likelihood of something blowing up? So if the likelihood so actually, okay, you know what? I'm sorry. It's going to be another video game example because why not? So when Skyrim first came out, Skyrim was a very ambitious game. And for those of you that don't know, it's sort of like a first-person experience in basically almost a simulator of a sort. So you'd be in some kind of Icelandic saga kind of thing. And so they're like dragons and people and all sorts of stuff. Anyway, one of my friends at one point was in this impossible situation where they had to kill his dragon, but the dragon kept flying backwards, and the dragon for some reason glitched out and was flying backwards, and as a result, they could never basically finish whatever the quest they were on. Now, I would say to you that a good question comes up. Well, why did Bethesda, which is the company, why did they release this product if that kind of problem could happen? And I would say to you that Bethesda had a limited budget. They can only test for so many possibilities. And so what they're looking at is how likely is it that some glitch would happen, and what's the overall impact on the system if that glitch actually did happen. I don't know. Of course, this is my one time I'm going to try this out. Let's see if this actually works. Okay, it works. So up here is basically the likelihood of it happening and the impact if it did happen. And so in the case of should we test to see if dragons ever fly backwards, the likelihood is pretty low, but the impact is pretty high in that this person could never finish the game. Now, in the case of, it will blow up if someone tries to log in after hours, well, the likelihood of that happening is higher, and the impact is also higher because the actual system's blowing up. Now, if it's another scenario where the likelihood of it happening is pretty high, but it's a pretty minor thing, that's another possibility here. And if the likelihood of it happening is pretty high and the impact is pretty low, okay. So what we got here is sort of, a very oversimplified grid. But here's what I'm trying to say. If it's likely that it's going to happen, and it's got a huge impact if it does happen, those kind of risks are going to have pretty significant mitigation plans, right? People are going to be looking for those. Let's imagine, for example, you're trying to withdraw money, and it's likely that it's going to all of a sudden give you too much money. Pretty big impact, and it's pretty likely they're going to be looking for ways to mitigate that risk. However, if it's likely it's going to happen, but it's really not that bad, and I'll say right now, for example, even YouTube has this, where I'm trying to upload these videos. And I'd say about 1 video out of 10 doesn't upload properly, but they don't seem to care. So there's probably no mitigation plans for that, right? Now, then you got these things that are not likely and big impact. This would be an interesting one for them to think about. You know, what is the likelihood that whatever this, if this thing is not likely to happen, but it's going to cause your program, your machine to shut down and reboot, like almost every single Windows 10 patch that comes through this system. I think, by the way, my home system is probably near the end of that technical usefulness. I think we're going to have to get another one soon. But anyway, do you create a plan for that? I mean, it's not very likely to happen, but it's a pretty big deal if it does happen. How do you mitigate that risk? And then over here, in this example, it's not likely to happen. It's pretty minor impact, and screw it. You're probably not going to spend any time on that. So I'd probably suggest you, obviously, you're looking at, I would probably go like maybe 1, 2, 3, 4 if I thought about priorities here. That's probably what I'd be thinking about. All right, well, that was cool, and I just wanted to kind of get that discussion. There used to be a nice little graph on that, and that's gone. And it makes sense. I mean, the previous bet of risk was really about security risks, but I did want to talk about this idea of just general risks as well, as we're getting closer to the end of the course. All right, now it's time to talk about backups. So we're trying to back things up. There are a bunch of different ways we can do backups. We can do full backups. Let's get my thing back. We can do full backups. Just my normal pointer, please. Laser pointer. Ooh, neat. We can do full backups, which is exactly what it says. It's a full backup. Now, typically, you're not going to back up everything every day because it's going to be full, right? And I will say that most of the time, we don't get a lot of full backups. Most of the time, you get backups that are what's changed, or maybe every day, right? Some time block, or if you're really lucky, continuous, right? Now, the reason these things don't happen that much is that they're pretty expensive, right? But there are different kind of backups, and even with the backups, what we got to think about. Okay, I guess they didn't bring this up, but anyway, when you do these backups, you got to think. Other questions are, where are the backups going to be? If the backups are, for example, on the same PC as your system, that's really dumb. So you're going to want to move the backup off that. Many times what you want to do is you want to have the backup located off site completely to some other place. And then you got to think about how long do you keep that backup? How long do you keep that backup, especially full backups? And so those are all the kind of questions that you're going to be wanting to think about when it comes to maintenance. And then this all gets to the idea of business continuity. There are two words that get used almost the same way, and they're not the same. Business continuity and disaster recovery. So right there, you can almost see it happening here. So disaster recovery, well, let me talk about business continuity first. Business continuity is basically trying to get your business to continue even in the event of a disaster. So actually this COVID is a really good example of business continuity, because what's happening now, people are trying to keep their businesses going. What's our plan? Everyone's starting to work from home, right? That's business continuity. Now, another example would be your machine goes down, right? That's running the server. What's business continuity? Now, what we have done in the past is that when the machine went into a critical failure, we still had another copy of it. We had our staging environment. You might have mentioned, I mentioned this earlier in the other lectures, that we had sort of a development, a build, a stage, and a production. And the stage was supposed to be exactly the same in data and in software as the production. So what we did is we made up a plan. We said, okay, look, production is going to be down for a week. Business cannot continue for that length of time without our system. So we shifted everyone. Business continuity was shifting everyone onto stage, and they ran their business off of stage. You can't live long like that. We needed to recover from the disaster of our production machine going down. So the disaster recovery effort was fixing our production machine so that it was back to normal. And then we shifted the business back onto production. At that moment, we've done our disaster recovery. So our business continuity plan was shifting everyone onto production, onto stage, getting to run from there, fixing production, and then bringing people back onto production. All right, cool. Then at some point, you got to retire the system. So at some point, the system is just not going to be continuing anymore, and it's got to be retired. I would say about this idea is that retirement isn't just turning the system off. When you retire the system, what you need to do is you need to basically communicate to users that we're about to retire it. Give them lots and lots and lots of notice that you're about to retire it. Maybe on the system itself, there'll be a big splash screen saying, as of June 5th, the system is being retired. You're going to be sending out emails. You're going to do all sorts of stuff. Then on June 5th, you bring it down, but you don't delete it, because there could be people out there that never got the message, and all of a sudden you get panic emails going, hey, how come the system's not up? What's going on? And then you got to talk with them and say, why are you still using it? What's going on? And you might actually have to bring it back from the dead. So you basically want to keep a backup of it. You might have to bring it back up, give them a chance to get off your system properly, and then bring it back down again, right? So disaster recovery, retirement isn't just an issue of turning it off. There's a whole method in there. You want to make this as smooth as possible for them. And so now they're going to talk about the future challenges and opportunities, and of course, sure, cybercrime, the advent of these things, cloud computing. For me, my actual new job is going to be the manager of cloud computing, cloud data engineering. So yeah, that is a thing now, right? And that's what I was actually doing at Oracle too before, was that we were moving our stuff to the cloud. So cloud computing, I've actually got to see that rise out of almost nothing, and it's amazing how quick that's taken over. It'll be interesting to see what COVID does. It really would be interesting to see what all this moving around and how we're trying to maintain our businesses while we're in our shelter-in-place environments. It's interesting to see what kind of impact will that have on the way that we do stuff. And then environmental, right? Of course, no one's talking about climate change at this point, because we're all basically hiding in our basements. But that's still a thing, right? Climate change is still a thing, and we're going to have to try and figure things out like that. And you can see that in the way call centers, I should say, computers, and all that. They're trying to be a bit more ecologically safe. Even the idea, when you have all this old hardware, I have a ton of old hardware, and I shouldn't anyway, just throw it out. It should be recycled, and who's going to do all that in a corporate setting? There is not too much in the way of credentialing for systems analysts. I mean, for project managers, there's something called the PMBOK, which is a project management body of knowledge, and you can get certified. Same with Agile, by the way, there's Agile certification. For business analysts, there's actually something called a BABOK, which is Business Analyst Body of Knowledge. I haven't seen anything out there for systems analysts, because mostly we tend to get certified in the technology that we're in. I don't think I'm anymore, I think it expired, but I was certified in some Oracle technologies. So that's kind of the deal there when it comes to credentialing. We don't see too much there. I would strongly suggest, though, that you guys, at some point, whatever technology you're in, join a couple of those groups. Keep yourself fresh. The learning curve on this. I knew one guy, he was the most important person on the team, and 6 months later he was let go because he was actually obsolete. And he was obsolete because he refused to learn the new technology. Because why would he? He already knew everything there was to know about the technology we were on. Why would he bother to go learn new technologies? 6 months went from being the most important person on the team to being released. I myself, I thought I was relatively safe from layoffs for the role I was doing. I got laid off. So thankfully, I kept going, though. I kept learning things, and that's what's enabled me to get into this position now. So even though I don't see necessarily any system analyst credentials, there's plenty of opportunities for you to keep learning, use the Udemy thing, use Coursera, use, people are throwing all this stuff up for free on the internet, which is one of the reasons why my line of business was under stress all the time. So there's plenty of opportunities to learn. And even though, like, I was, for example, dealing with database stuff, but yet I still ended up learning a lot about Python because I was actually trying to teach a class, and it was using Python. One of the reasons, by the way, I teach at these colleges is to keep me fresh in technology. So I know that many of you, the last thing you want to hear at this stage in your life is that, oh, you get to take more classes, but definitely take every training opportunity you can and keep yourself fresh. I think pretty well the last real thought here is this idea, which is important, right? As a systems analyst, and I know that many of you are thinking you're going to be a systems analyst, you're going to be network people, you were forced to take this, you just want to be programmers, and I get it. But at the end of the day, a systems analyst is sort of what a network analyst could evolve to become into. Not saying it's better, by the way. We're saying that you could just by nature end up becoming a systems analyst. If you're a database person, you could still end up becoming a systems analyst. Programmers, you could certainly become a systems analyst. And what's really important, most of you probably have already the critical thinking skills. I mean, all those little assignments I'm trying to give you are ways to exercise your critical thinking. What we're missing in an online environment is the ability to demonstrate soft skills, which is kind of unfortunate, but that's just the way it is. So, but you might, if you're an introvert, not so much an introvert, because apparently I'm an introvert, but you might, if you don't have a lot of experience talking to people, you might want to consider doing something like Toastmasters, like actually learn how to talk in groups. It's not a bad deal, right? And also try to get a little bit more, social, emotional intelligence as well. Just say, if you don't have any of that, you're still fine, by the way, because there's still plenty of spots in this position for you. One of the reasons I like IT is there really is a spot for almost everybody in IT. You should ideally have some critical thinking, you think. But if you don't have critical thinking, go into sales. Just kidding. I'm not going to say that. But anyway, I'm saying that it is a pretty wide or large table for us out there. But definitely soft skills is an important idea, and I want you guys to sort of think more about getting those if you don't have them already, because you're not just dealing with technical skills, you're dealing with ethical skills or ethical issues, social issues, and even potentially legal issues. One of the problems I had is because I was dealing with a global company, is I had to deal with a German legal issue. I'm not a freaking lawyer, but I had to deal with my system from a German legal perspective. Some of the stuff I was working on, I was wondering, is this ethical, what we're actually doing? So it isn't just an issue of coding, the IT world. The IT world has got a lot of this in it, and so that's where systems analysts kind of rise up and try and help out there. All right. Well, that was kind of it, and that was it for this chapter. And although there's going to be another video following this, that was more or less it for this course. So I'll take this opportunity to basically say that it's been interesting and fun to try and basically put all this content out there together. I'm absolutely sure it wasn't perfect. I did my best, but what I'll be trying to do is reach out to you guys through emails and things like that, and look over your stuff. But for now, that's it for this video, and then I'll just basically get this last one done. But as far as the course goes, it's been fun, and we'll see each other around in the cyberspace later.